Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at an example using transformation rules on one of our parent or library functions. In this case, we're using f of x equals x cubed, shown there below, and we're going to use our knowledge of transformations to create g of x equals 2 times negative x cubed, and we're going to start by describing the transformations that are occurring. So I've got two things occurring here. I've got a 2 multiplier on the outside, and I've got a negative multiplier on the inside. So starting with that 2 multiplier, I can think about my acronym OVER. Over. Things that happen on the outside make a vertical change. They do exactly what they look like, and they affect the range or the y values. So I know that multiply transformations make compressions and expansions. So a multiplier on the outside is going to make a vertical. Let's see, I'm multiplying by a number bigger than 1. So exactly what that looks like, that would make me think an expansion. And that's going to be by a factor of 2. So that means each y value is going to get multiplied by 2. Now looking at my negative multiplier on the inside makes me think of the acronym IHOD or IHOD. That tells me that inside transformations affect my graph horizontally. They do the opposite of what they might initially appear, and they affect the domain or the x values. So a negative multiplier always makes a reflection. So in this case, that's going to be a horizontal reflection or flip. And a horizontal reflection left-right, that would be over the y-axis. Okay, when we have more than one transformation, we need to think about our order of operations. So both of these transformations are due to multiply. So in this case, it doesn't really matter which one we do first. So I'm just going to go left to right like we normally would do on order of operations. So I'm going to go ahead and first do my vertical expansion by 2. Now my kind of general points that I have noted here that fit on my graph, I have -1, -1, 0, 0, and 1, 1. Now we can think about we're going to be multiplying each one of these y values by 2 because we know outside affects the range, which means it affects the y values. So at a -1, my y value is currently -1. Multiplying that by 2, I get a value of -2. So now I have -1, -2. At 0, 0, multiplying my y value of 0 by 2 still leaves me at 0. So that one's not changed. And 1, 1, multiplying my y value of 1 by 2 gives me a y value now of 2. So I can kind of see that my graph looks like it's been grabbed from the top and the bottom and stretched out like taffy. So that's seeing my vertical expansion by 2. Now, before I connect the dots, I want to come in and add my horizontal reflection or my flip over the y-axis. So this one I think is best done just kind of visually. So take each point and it's going to reflect over the y-axis. You can also think that we're multiplying the x value by a negative. So my -1, -2 point, if I flip that over the y-axis, I land over here at +1, -2. 0, 0 point, multiplying my x value by -1, 0 times -1 is still 0, so that point again does not move. And my 1, 2 point, reflecting that over the y-axis, puts me over here at -1, +2. So there are my nice points coming in and connecting with that x cubed shape. I have a curve that looks something like this. So there's my graph of g of x, my x cubed with a vertical expansion by 2 and a horizontal reflection over the y-axis. All right, guys, that does it for this video. We'll catch you in the next one.